Okay, welcome to my YouTube channel. I just want to say thank you for returning. If you're an old subscriber or if you're an old viewer, thank you for returning. If you're a new viewer, please don't forget to subscribe and like this video and share it to your friends as well. Otherwise, this video our team believe that this video will be of great use to you in your studies. Okay, let's start. So in this video, we're going to look at what time. Symbol used to measure time is what? Small letter t. The SI units for time is what? Second, small letter s. This is what I'm emphasizing, that small letters here, they are very important. If you change it, if you write this in capital letters, your answer will be wrong. And if you write this in capital letters, your answer will still be wrong as well. So definition, what is time? Time, it is the measure of how long matter occupies a given space. So that's the definition of time. It's a measure of how long matter occupies a given space. A time measurement enables us to determine the interval between the beginning and the end of an event. So time helps us to determine the beginning and the end of an event. Other units for time, you have what? Minutes, of course. You have minutes, hours, days, months, years, and centuries, even millennium, centuries, all those things are units of what? Time. But the SI units, which means the basic units, or the units which they require you to use in physics, is what? Seconds. Anything apart from that is what? Is wrong. So how do you conversion of units of time into learning that okay, 60 seconds is equals to 1 minute, then 60 minutes is equals to 1 hour, then 24 hours is equals to 1 day. So which means if you want to convert this, is just simply cross multiply. This is how you convert what? This time. So this is what they mean when they say 60 seconds. They simply mean this is what? 1 minute. 1 minute. Okay, we move on. So here we have summary of time, summary on measurements of time. Okay, instrument. Okay, let's look at the instruments which are used to measure time, or the summary of time. This is what the summary. 1 year is equals to what? 365 days. In 365 days, we have how many hours? We have 8,760 hours. And that's in these hours we have these minutes, and these minutes we have these seconds. So technically, these seconds are there in these main seconds are there in the what? In the year. Okay, that's clear. Okay, before I continue, here's your exercise again. I'll pause this video for just 1 second or 1 minute for you to read this question exercise. Copy it if you have the book, which is the best thing to do. Here you need to question 1, read this exercise, convert the following to stated units. So you have you have 120 seconds to minutes. You need to convert these seconds into what? Into minutes. Using what I've taught you there, then you need to also to do what? Convert 30 minutes into hours. Using what I've taught you there, I've explained. So if you haven't understood, you can just read backward the video, then you listen properly. If you don't listen in the video, please don't go for another video. Just leave a comment, then I'll respond to you immediately. Okay. Okay, now we look at instruments which are used to measure what? Time. So instruments for measuring time, we have what? You have a simple pendulum, stopwatch, you have tick tape, you have a tick tape timer, you have oscilloscope. All those things are used to measure. All these which are here are examples of instruments which are used to measure what? To measure time. So the simple pendulum is the first example we can use to measure. As another example, or another instrument which you use to measure what? To measure time. So a simple pendulum is a small heavy bulb suspended by a light extension stable string. A simple pendulum is a small heavy bulb suspended by a light extendable string. This consists of a string tied to a horizontal support. A bulb is suspended at the lower end of the string. Okay, so here is what a simple pendulum. Simple pendulum support. We have supporter. This is a supporter point of suspension. You have the light string. This is the string we're talking about. Then you have this bulb. This round things are the bulb. In the center of the bulb is here, the line drawn. Then this line from here, or the distance between this point and this point, we call it what the length of the pendulum, which is L. Okay. I hope I haven't lost anyone in terms of explanation. Okay, now we go to terms used to describe a simple pendulum. So we have oscillation. Alternative term, you have vibration, circle, or swing. So oscillation simply means a swing, a circle, or vibration. This is what it means. And definition of a circle is what? An oscillation is an oscillation is a complete to and from movement of the bulb. So when I say it's a complete to and from movement, I simply saying in order for us to set this bulb from it has moved a complete oscillation, the bulb needs to move from point A to point B to point C, back again to point B, again back to point A. That's what we call a complete movement of a bulb. In other words, oscillation. Okay. Okay, so you need to note that a swing from A to B. When they say a string from A to B, let me just get the diagram properly. I put it properly here. Yeah, I should be able to see when I do this. Yeah. Okay, so we have so you need to know that a swing from A to B from here to here is 1/4, or in decimal place is 0.25 oscillation. So from here to here is 1/4. Then from A to C is 1/2. Simply is C. 1/2. Why is it 1/2? Because from here to here is 1/4, which means from A to B is 1/4. Then from A to C is 2/4. So since it's 2/4, you can simply say 2 into 2, you're going to have 1 on top, and 2 into 4, we're going to have 2. That's why these 2 are 1/2 has come from, or 0.5 oscillation has come from. Hope you have gotten that. Then the next thing to do, you need to, from movement from A to C back to point B is 3. What they are saying is that from point here A, which is here, to here and back again to, so movement from A to B to C and back to B again is 3/4, and this is 0.5 oscillations. That's what they mean. You need to understand this movement because it also comes both in physics, science, and pure as well. Then if a bulb moves from A to C and back to A again, that's what we call a complete oscillation. It's as simple as that. The amplitude, now we need to measure what? Amplitude. What is amplitude? Amplitude is measured symbol is A. SI unit is what? Meters. We are done with time. Then definition of amplitude. Amplitude is the maximum displacement of the bulb from the rest position. Yeah, the maximum displacement, simply how high the bulb has gone. That's what we call it, amplitude. The length of the pendulum. Length of the pendulum, symbol L. SI unit is what in meters. Definition, the length. Length of the pendulum is the distance from from the support point of suspension to the center of the bulb. Then we're going to have a period of the pendulum. Okay, then just move my screen a bit. Okay. So we're going to have the pendulum. Simple pendulum, period of a pendulum. So its SI unit is what? T. Symbol is what? Capital T. And I explained at that time for video when calculating time earlier on in this video. I said that if you want to measure time, the SI unit of a symbol for time is small letter T. Why not using capital letter T? Because if you use capital letter T, you are saying something else. You are actually saying that T is a period. In capital letter T in physics simply means period. The SI unit is the same as time, which is second. Definition of the period of the pendulum is the time taken by the bulb to make a complete oscillation. In other words, the time taken for the bulb to move from point A to B, C, back again to B and A. That's the time taken. That's what we call what? The period. Now we need to look at the factors affecting the period of the pendulum. So the first factor what we have the length of the pendulum, which is L. We have acceleration due to gravity. These are the factors which affect what? The pendulum. The period of what? The pendulum. So these questions also come in the exam. You need to know these 2 points. They are very important. Then you go to A, length of the pendulum. Period of the pendulum becomes longer if the length of the pendulum is increased, shorter if the length of the pendulum is reduced. Acceleration due to gravity. This is how it affects. When gravity is high, the period reduces. When gravity is low, the period increases. Now we need to know factors that do not. There's a difference here. Factors that affect and factors that do not. So in the exam, a question can come saying that what are the factors that affect the period of the pendulum? So you need to mention these 2 points here. Then when the question comes in the exam, asks you to state to explain the factors that do not affect the period of the pendulum. You need to mention these factors here: the amplitude of the swing and the mass of the bulb. Period does not depend on the mass or material of the bulb. Okay, I hope you have gotten that. That's simple and straightforward. When we move on to the next part. Okay, now I have precautions. When using a simple pendulum, the precautions are the things you need to consider before using a simple pendulum. You need to consider what? Sorry about that. You need to consider the location of the pendulum should be in place where there is less or no wind blowing. That's what you need to consider. The next thing you need to consider is you need to provide this small amplitude to reduce effects of air resistance. You don't have to set the ball very high. If you do that, air resistance will get involved. Hence, you have wrong measurements. So to avoid air resistance getting involved, you need to use just a small amplitude just for correct measurements. Then you need to use the length of the pendulum to reduce its frequency and easy contain. Okay. Counting of oscillation. Okay, this is the relationship between period and time. time is equals to number of rotation times period here. Okay, thank you for watching my channel. Next video we'll look at frequency of the pendulum.